Thank you for joining us for today's webinar, Charging Ahead, the State of EVs in 2022. It is part of the LES Sustainability Series. I'm Shireen Othman, Communications Specialist at LES. We'll take questions at the end of the presentation, so if you have a question, you can raise your hand and I'll unmute your mic, or you can use the chat box. Presenting with us today is Mark Skolnick, Manager of Energy Services. Mark, I'll go ahead and hand it off to you whenever you're ready.
Well, thanks a lot, Shireen. I trust you can hear me. Appreciate everybody taking time out of their busy schedules to join in this conversation about electric vehicles. I want to point out, first of all, that I don't consider myself to be an expert on electric vehicles, although I did sleep at this Holiday Inn last night. I will tell you that there are many on the webinar today that have tremendous expertise, and it's great to bring together people with different backgrounds and understandings of electric vehicles. I've had the opportunity to read a lot about electric vehicles, participate in some meetings with a lot of folks that do have a lot of subject matter expertise in electric vehicles and in electric vehicle charging and a variety of different technologies that are emerging. And so I'm kind of excited to share some of what I've learned, but it's one of those things where we're always learning. This is emerging. It's very new. And so things are changing all the time. And that's really one of the more exciting aspects of this. I thought I'd start by asking you to participate in a couple of poll questions just to get a feel for your background with electric vehicles. So the first question I'm going to have Shireen put up for you to answer is to better understand your knowledge and background with electric vehicles. So Shireen, if you want to pop up the first question. This is on a scale of 1 to 5, with 5 being that you should be teaching this webinar, you have that much expertise, and 1 being that you have very little knowledge of electric vehicles. How would you rate your overall experience and knowledge with EVs on a scale of 1 to 5? And I can't necessarily see if the question's up or not. Shireen, can you confirm that poll question has been up?
I did launch it, but if anyone's having issues, just let us know.
If you see responses coming in, that's great.
Yep, it looks like we've got respondents.
Super. All right, so let's see what the responses are. And Shireen, you might have to share that with me as I'm unable to see the question itself up on the screen.
So we have 46 responses, and it looks like 41% rated it as 2, 23% as a 3, 19% at 1, 10% at number 4, and then 4% at a 5.
Okay, so we have a little bit of diversity here, and so that's good. We got different levels of experience with EVs. Hopefully, you'll take something away from today's conversation that you knew or that you didn't know. And maybe some of the things I'm going to talk about confirm what you already know. One other question, and that is to understand who currently owns EVs versus those who are just curious versus those who are planning to purchase an EV in their next purchase. So if you want to pop that question up, the question basically is indicate if you're an EV owner, or if you're not, if you're planning on buying an EV as your next car, or if you're just kind of curious. And we'll let the answers come in, and then Shireen, when you shut that down, you can go ahead and share the results.
We've got 53 responses, and it looks like 64% of people are just curious, and 26% don't own a plug-in vehicle, but their next vehicle may be a plug-in.
And how many EV owners do we have?
9%.
9%. Okay, very good. You know what? One of the most enjoyable thing is to talk about the I'm Just Curious group. A lot of the folks in the I'm Just Curious are really wanting to get a lot of questions answered. They want to know what the experience is like. And so really, we have endeavored over the last several years, LES has endeavored to bring together those who currently own EVs with those who are curious, because really it's that group that is interested in a lot they have a lot of questions. They need to have a lot of answers before they make that decision for a variety of reasons, and we're going to get into that. So thanks so much for your participation in those two questions. What I'd like to cover a little bit today in this time we're together is, first of all, I'm often asked, is this EV thing just a fad? Is it just something that is kind of, sizzly right now, but will eventually go away? Number two, if it isn't a fad, how quickly do we expect customers to adopt EVs? I mean, are we going to be challenged to serve electric vehicles as an electric company if we have this quick adoption of electric vehicles? So we're going to talk a little bit about how technology is adopted. There's some modeling that has been done across all types of technology to give us a kind of an answer to that. Also want to talk a little bit about the benefits of electric vehicles compared to internal combustion engine vehicles, and also how charging works. And then we want to allow time for good interactive conversation here at the end. So let's talk about this first one, and that is this EV thing just a fad? All right. I don't know if anybody remembers this sock puppet, but this sock puppet, and if you don't recognize that sock puppet, there's probably a good reason you don't recognize that sock puppet. It was the mascot for Pets.com. And Pets.com was an internet startup. It raised $82 million when it went public at $14 a share in 2000, 22 years ago. And by the time it went out of business, just 9 months later, it sold at 22 cents a share. And some of you may remember the Super Bowl 24 in 2000. It was just overrun by .com commercials that they bought those expensive slots during the Super Bowl. Those are some of them, that Epidemic.com, eStamp, all those .com companies spent millions of dollars to advertise their internet startup in 2000, and within months they were gone. And so I guess my question then is, was the .com business just a fad, right? You had all these startups, a lot of venture capital going into them. Some of them went public, many of them went away. Was the .com business model a fad? Well, not really. Amazon, Google, Facebook, Netflix, which, by the way, Netflix is starting to have some of its market share eaten into by a bunch of other streaming services. I wouldn't say that the .com business model was a fad. It took some of these businesses to figure out how to capitalize on the platform. And I think I would draw a comparison to electric vehicles. One could say that the brick and mortar style of selling products and goods and products may have been a long-term fad, because we've seen a lot of closings of brick and mortar stores that have been replaced by Amazon and have been replaced by streaming movie services like Netflix. And so it's not unusual to have the early activities, the Wild West, if you will, of innovative businesses, and then a shakeup occurs, and then the real stalwarts begin to emerge that have things kind of figured out. The electric vehicle has a long, long history. I'm not going to go back into the 1800s and the 1900s on electric vehicles, but there were electric vehicles back then. It just, for a variety of reasons, didn't take on. But there was an effort in the late 90s to take a look at electric vehicles using lead, acid, and nickel metal hydride batteries, the EV1. General Motors leased these vehicles for a period of time. And if you look at that vehicle, it looks like an electric vehicle. It looks a little odd. I don't mean to hurt anybody's feelings that may have, on this call, that may have leased one of these vehicles, but It was more of a proof of concept. It had some limited success, 60 to 100-mile range on the battery technology it was using. And you also need to realize that climate change as a national cause or as a national issue was still somewhat in its infancy. Those who were really into the climate understood this to be a future challenge or one that needed to be tackled, but it did not receive the amount of attention that it certainly does today. And there was a lot of resistance from major automakers and other special interests. And so most of those EV1s were gathered up and were crushed. There's actually a movie called Who Stole the EV, the Electric Vehicle, or I'm trying to remember the name of the movie, but there is a movie about what happened during this period of time and how General Motors went around to all those leased vehicles, gathered them up, and crushed them. And so this was kind of the end of that era. But now compare that to what we're looking at for today. And these are the kinds of vehicles that are available. And this is just a limited number of the models that are available. If you notice, these vehicles look like conventional vehicles in many respects, very sleek, very modern, but they don't look odd in many respects. They look like vehicles, the kinds of vehicles that people would want to purchase. They are using lithium-ion batteries, which are far more advanced, far more efficient, pack a lot more energy density than the lead-acid batteries. They have much longer range. We also know that climate change has become more of a national and a global issue. And automakers are responding. Chevy and Ford and Stellantis, and then there's been the emergence of the newer players. But obviously, Tesla is the one that really got into this early on and has delivered to the market and has really driven the market, particularly with the Model 3. And so it's a whole different day, but we're still talking about electric vehicles. So I think one could safely say that this is more than just a fad, that this is actually something that is actually happening across the country. And in fact, we're going to see in a little bit, it's happening globally at a much larger scale. So if this is more than just a fad, how fast do we expect customers to adopt electric vehicles? So I'm going to have another poll question put up to see what your responses are. We had 90 to 100 customers who participated in a 3-year study that we conducted to understand the charging behaviors of residential EV owners to see when, for how long, and where people charge their vehicles. And we gathered those folks, the prospective participants in the study, we gathered them together a few years ago, and we asked the question, what was your primary motivator for buying an electric vehicle? And there were 4 options: environmental benefits. So I'm a steward of the environment, and my way of demonstrating that is by, one of the ways at least, is purchasing and driving an electric vehicle. Another option, another motivator, primary motivator, was the economics of driving an electric vehicle. A third option that I asked is it more about the advanced technologies and features of electric vehicles? Or D, is it the performance of the vehicle? So I want you to kind of weigh in and indicate what you felt was the driving factor of those 90 to 100 customers, and we'll see what we come up with here. And I think Shireen's put that question up. And Shireen, once you believe all the results are in, you can share what you see.
We've got about 52 responses so far, and it looks like most people, their decision to buy was for environmental benefits, followed by economic benefits.
Okay. Well, that is a very good guess on people's parts, because that's indeed what it was. The overwhelming majority of the folks, almost unanimous, not 100%, but it was close to unanimous, is that folks in this group were driven to purchase an electric vehicle primarily for environmental benefits. Again, not everybody, but an overwhelming majority had an environmental motivation to purchase an electric vehicle. And that really fits into the diffusion of innovation theory. The diffusion of innovation theory was first introduced by a professor at Ohio State by the name of Everett Rogers, a professor of communications at Ohio State. In his book, Diffusion of Innovations, published in '62, basically, Rogers said that adoption of technology is largely a function of how the technology is communicated over time through a social system. But there were 5 main elements that influence how quickly innovation spreads. The innovation itself, the adopters, communication channels, time, and a social system. And so what we're looking at today is that there's really a couple of groups that tend to be the early adopters when technology is introduced. The first is the enthusiasts, the individuals that just want to be first when it comes to certain technology. If you think about when Apple comes out with a new version of the iPhone, these are the individuals that would stand in line at the iPhone store early in the morning to be among the first to get it. And so they're just certain individuals, about 2.5% of any given population is what was found, that want to be first. And they're not necessarily drawn by any cause other than they want to be the first to see the technology, to have the technology. They can be very critical of it once they get it, but they want to be first. The other cohort within the early adopters and a little larger group is those that are motivated by a cause, right? They also tend to be fairly influential, and they're comfortable taking risks. And so these are visionaries, these are part of the early adopters, and I would suggest that many of the folks that were part of our study that were there that evening when I asked are motivated by a cause, and that's the climate. And so it certainly makes sense that the first 16% of any given population would be in this early adopter group that would either be individuals that want to have the first in technology and or they're motivated by a cause. So really, in order for a technology to become sustainable and to grow significantly, you have to get into the early majority, which is a very different group of people. The early majority, which constitutes about 34% of any given population, they only take on new technology when it's proven. They're not as much risk takers. And so they're looking for the technology to be proven, and they're looking for a lot of answers to questions. And so those of you who are in the curious, if you indicated you were curious about EVs, you haven't made the decision to purchase one, many of you would fall in this pragmatist cohort because you've taken the time out of your day to come listen, right? We may not find the next cohort even online today, possibly some, but these are conservatives that are extremely cautious. They absolutely don't want to take any risks at all. And so that's another 34% of the population. And then the tail end of the curve are the laggards, and they will go kicking and screaming into the future with new technology. They like what they have, they don't want to change, and 16% of the population tend to fall into this category. And what's really interesting is Jeffrey Moore in 1992 came out with a book called Crossing the Chasm, and basically said, you don't hit a tipping point until you're able to cross the chasm. And there is a chasm between the early adopters and the early majority. And some of the issues as it relates to electric vehicles that are in this chasm is, number one, are the models of vehicles being offered what people want? And if you would have asked me a couple of years ago, I would have said that the technology has a ways to go. But I think this is really being addressed because 75% of the vehicles on the road today fall in 3 categories. They're pickups, they're SUVs, or they're crossovers. And what are we starting to see starting this year is pickup trucks and crossovers and SUVs rolling off the line, either plug-in hybrid or all electric. And so the industry is addressing that potential barrier to the tipping point. Another item that needs to be addressed to cross the chasm is range anxiety, which basically means that people are concerned that when they get in their electric vehicles, and if they particularly go long distances, they're not going to be able to get to where they want to go. That there needs to be charging infrastructure that's reliable, that they can count on for them to go long distances. Even though a vast majority of our travel is within a very short distance of our home in most cases. We have a paradigm where we want to have a vehicle capable of going 300 to 400 miles without having to fill up a tank of gas. And that's what we've been trained to do. If we really think about it, again, most of our travel is within a 20-mile round trip range on any given day in Lincoln. But range anxiety is a barrier and needs to be addressed. And of course, advances in battery technology will help with that and is helping with that, but it is something that needs to be addressed. Price is another thing. Price is a big deal, and there are federal tax credits that are available, but price on a lot of these models, particularly the ones that like pickups and crossovers and SUVs, prices are still rather high, and until they come down, that will be a barrier to adoption. And then reliable EV public charging. A lot of the public charging, we'll talk about what level 2 charging is, but it's kind of the mid-range speed of charging. It's fairly reliable. And the Tesla fast charging network across the country is also very reliable. But the non-Tesla DC fast charging isn't quite up to snuff right now, and that gives people pause if they want to take long trips over the highway. They want to be sure that when they pull up to a charging station that it is going to work. So these are some of the issues. These aren't all of the issues, but they're some of the big ones that need to be addressed before the early majority gets into the game, if you will. Now, one of the big surprises to people is how the U.S. is not the biggest player in the electric vehicle market right now. This will show you through 2021 that how EV sales have grown in the U.S. Through 2021, 4% average across the country, 4% of sales went to plug-in vehicles, mostly battery electric vehicles, but that does include plug-in hybrids. But look at Europe and look at China. We're talking upwards of 18% or more. We're talking millions of vehicles overseas, and this is during the pandemic. There is a lot of public policy in those nations on driving a lot of those sales, but the numbers really do dwarf what's happening here. And so what's happening on the global stage will have an impact, I think, here. I think that overall we may see more models and we may see some price declines just on the economies of scale that are happening, but there's a lot of activity going on in Europe and China. And if you look, Norway, around 72% of sales in 2021 were plug-in vehicles. And they have a wide variety of policies and requirements and restrictions that are leading them to a point where just about all vehicles will need to be electric or carbon-free, at least in the future. And we're starting to see some of that. I know California has a goal to do that either in 2030 or 2035. But just know that the United States is not leading the world in sales, but we're following along. And if we look at the United States, this is a heat map of sales in 2021. The lighter colors tend to be the higher percentages of plug-in vehicles, 4.3% nationwide. And you can see that along the West Coast and in New England, the higher percentages of vehicles. If you look hard enough, you'll see Lincoln in a little bit of a lighter magenta type color. And we're probably in that 1 to 1.5% of vehicles purchased in 2021 were plug-in vehicles. But this gives you an idea. I also want to point out that there are a number of states, and it's kind of hard to see on this map, but the aqua outlined states are what are called ZEV states, zero emission vehicle states. And there is a requirement in those states that 20 to 25% of vehicles sold must be zero emission. So any auto manufacturer selling vehicles in those states essentially have to be electric. There isn't a whole lot of hydrogen. There are some, but it's almost all electric. And so public policy is driving the sales of those vehicles in those states. There are several states that are becoming or have just become ZEV states, including Colorado. So that's driving some of that as well. As of the second quarter of this year, Nebraska had over 5,600 registered plug-in vehicles. 60% of those are all electric. And in Lincoln, there are over 1,000 plug-in vehicles, and also 60% of those 1,000, so 600 to 700, are all electrics. And there used to be a time when you drive around and you'd notice for example, a Tesla, and that was kind of a novelty. And now it's almost difficult not to drive around town and see a Tesla or another electric vehicle. It's become much more commonplace. This slide kind of shows how sales have gone since 2010. There's been over 2.5 million electric vehicles sold nationwide. This chart also shows, if you see the dotted line, that's been the growth in plug-in hybrid electric vehicles. Those are vehicles that you can plug in and have maybe 20 to 30 miles of range, and then they switch over to an internal combustion engine. And then you can see the solid line shows the growth of the all-electric vehicles. Tesla is the leader in the all-electrics and in plug-in vehicles overall. But then you've got Chevy, Toyota, Ford, Nissan, and so forth and so on, making up the rest of that growth to where we are at over probably 2.5 million, definitely over 2.5 million electrics in the United States right now. Well, let's talk about the benefits of electric vehicles, and my colleague at NPPD, I think, really summed it up in this slide here. There is savings to be had. We'll get into that a little bit in terms of how does that actually work. But fuel and maintenance costs are about 70% less on average for an electric vehicle. Number two, there is emissions benefits. Even with the utilities that, utilities certainly use a certain amount of fossil fuels, natural gas or coal, there's still carbon savings by driving an electric vehicle in terms of not having the tailpipe emissions. And utilities continue to add renewable resources, wind, solar, and others to the mix, so that's an ongoing process. Also, the electricity that is used for the home and for the vehicles, for electric vehicles, are domestic in many respects. However, it would also be important to point out that the materials used in batteries, at this time at least, are sourced overseas, and there's a concerted effort to be able to source those battery materials either here domestically or with countries that are friendly to the United States. And so that's kind of part and parcel of the federal tax credit and changes that were part of the Inflation Reduction Act that was recently signed in August. And then we also see that electric vehicle owners tend to have a higher satisfaction level because there are some really great performance features of an electric vehicle. And if you've never gotten in one, you need to consider doing it. The ability to press on the accelerator and just go, there's no hesitation in it. The regenerative braking, when you lift off the accelerator, energy goes back into the battery. That provides not only efficiency, I also feel like it provides a little bit of safety, that you're automatically slowing down when you take your foot off the accelerator. Those are some of the performance issues that I think people enjoy about electric vehicles, among many other things. I mentioned efficiency. The internal combustion engine vehicle is not a very efficient vehicle. Only about 20% of the fuel, the energy from the fuel goes to providing that torque to drive the vehicle, whereas an electric motor is much more efficient. And this is really important. Not only is the fuel electricity on an apples-to-apples comparison to gasoline less expensive, the really big thing is that the technology itself is more efficient. And I think I draw the comparison with an incandescent light bulb versus an LED. The incandescent light bulb only used 10% of the electricity to light the bulb. The rest was wasted as heat. I think that the internal combustion engine is somewhat analogous in terms of how much heat is lost and how much inefficiency there is in the internal combustion engine. And the other thing, of course, is an internal combustion engine. A conventional vehicle has many, many parts, over 2,000, where an electric vehicle is a fairly simple machine with about 20 moving parts. So you have reduced maintenance, and that also leads to some of the efficiency that you get in the electric vehicle. So let me maybe run down how the costs compare. This one here. So 33 kilowatt hours has about the same energy potential as a gallon of gas, and 33 kilowatt hours using LES's energy rates costs about $1.98. So $1.98 a gallon. If you go to a DC fast charging site, you're going to pay more than that. You're paying more than that because the amount of power and infrastructure required to provide high amount of power that you wouldn't necessarily have available at your home. So when you do the math on that, at 30 cents a kilowatt hour, which is kind of typical for DC fast charging, that's $9.90 a gallon. You may say, well, goodness sakes, that is outrageous. You have to remember the efficiency of the vehicle more than compensates for what that $9.90 per gallon cost really is. We're going to compare the operating cost to this cost per gallon of gas. This is off the AAA website from mid-August, when prices, and I think they're still in that $3.50 a gallon range across the states, a little bit more across the country. And then also remember that there is no routine maintenance required on an electric vehicle. In other words, no oil to change or other fluids. It's basically tires, windshield wipers, very few things, whereas a typical vehicle is going to need oil changes and other types of maintenance, and it works out to be about 1.3 cents a mile, or about $65 per every 5,000 miles traveled of maintenance. So, and really, in order to make an apples-to-apples comparison in operating costs, we're going to do this on a cost per mile driven basis. So an electric vehicle is given the numbers above in terms of electric prices and range. In town, you can drive about 1.77 cents per mile, and on the highway, it's a little bit more. And it's kind of counterintuitive because we're always taught that our mileage and our efficiency improves when we're driving on the highway. But when you're in an electric vehicle, you actually get more range when you're in town because of the regenerative braking. Braking actually puts energy back into the battery, and so you can get longer ranges in town. So 1.77 cents per mile in town, about 8.86 cents per mile on the highway, and that's also including some highway DC fast charging. And so the typical vehicle that travels 90% in town and 10% on the highway is going to average across a year about 2.48 cents per mile. And if you're a little bit more on the highway, maybe 20%, about 3.19 cents per mile. Now let's compare that to the internal combustion engine vehicle at different fuel efficiencies. 20 miles per gallon, 17.5 cents per mile, all the way to 40 miles per gallon at 8.7 cents per mile. You can see that the cost per mile is significantly less for an electric vehicle. And if you look across an entire year, using the two different scenarios of 90% in town and 80% in town, you're looking at about $300 spent on fuel, which is essentially electricity, and about $382 if you travel just a little bit more on the highway. And these are costs associated with gasoline and a little bit of additional maintenance. And you're talking about 80 to 90% less costs than an internal combustion engine, depending on the fuel efficiency. So it is certainly significant in terms of fuel and maintenance savings when you look at an all-electric vehicle. The last item I thought I'd cover before we open up for Q&A is charging. Chargers are typically rated in your in kilowatts. That's just the amount of power that is capable from a particular charging source. It's the rate of energy transfer over time. So the higher the kilowatt, the quicker it'll charge. And then when we talk about batteries, we're typically talking in kilowatt hours. That's how much energy can be stored. You can see that the battery packs in vehicles continues to lengthen. At the top there is the Ford F-150 Lightning, which has a 145 kilowatt hour battery. You figure 3 to 4 miles per kilowatt hour, you're talking well over 300 to even 400 miles of range for that Ford F-150 Lightning. And you can see that it goes down from there. The Tesla Model S has a long range at 100 kilowatt hours. Again, you're talking 350 to 400 miles of range in most ideal weather conditions. I'll mention here in a moment, there are elements that do reduce the range of batteries. But you are talking about rather expensive vehicles too in those categories. The Chevy Bolt, which is a little bit more economical in price, has a 65 kilowatt hour battery. And you can get ranges over 200 miles, usually in the 220, 230 mile range in the Chevy Bolt. And there are different efficiencies as well. The Tesla Model Y, you can get 4.1 miles per kilowatt hour, which is very good with an 80 kilowatt hour battery. And then the Mach-E, the Ford Mach-E, you get about 2.8 miles per kilowatt hour. So each vehicle manufacturer is working on enhancing the range and the energy intensity and efficiency of those battery systems. So I've mentioned before, there's a variety of factors that do affect driving range in an electric vehicle. The weight of the vehicle, whether you're running the heat or the air conditioner can reduce range a little bit. The design of the vehicle, that's why you do see vehicles are typically pretty sleek, cut down on the wind resistance. One of the biggest things is cold temperatures. So you will see a fairly noticeable decrease in range, maybe 20 to 30% in really cold conditions, cold windy conditions. And of course, how you drive the vehicle. If you're slamming on the accelerator all the time, that'll reduce your range a little bit. And as I said, in town, you actually can extend range with all the braking. And on the highway, if you're obviously not braking as much, you wouldn't get the same range as you'd get in town. What we did find in our study, and this is generally true across the board, is that most people fuel their vehicle, charge their vehicle at home. And that happens well over 90% of the time. Whether you plug into a standard 110 outlet or you put in a higher 220, 240 volt dryer type outlet where you can get at least 20, 25, maybe more miles per hour of charging. And then, of course, you can use public charging infrastructure, whether you're looking at traveling across the highways or there is also public charging becoming available. There's still a ways to go in multifamily developments and also in retail centers and at work and that type of thing. There's basically 3 levels of charging. The first one is, as I said, level 1. That's typically what we call a trickle charge, where you're just charging into a standard outlet. You get about 5 miles of range per hour, essentially. And think about it, well, round trips in a city like Lincoln are about 20 miles round trip. You could get plenty of range just by trickle charging. If you bump up your service, if you bump up your circuit that you're using for level 2 charging at home, you can get about 25 miles of range per hour. And you can also find public charging that provides even faster charging than that. And then there's the heavy-duty DC fast charging, which provides over 100 miles of range per hour as you travel along the highways. This is a map that shows where charging infrastructure is located across the state. The interstate is pretty well served. You may have read that the federal government is providing dollars to the states to add more DC fast charging along the alternative corridors, which they're calling pretty much the interstate systems. So I'd say within the next couple of years, non-Tesla vehicles will be able to get to fast charging very easily. Tesla has basically built out their infrastructure along the interstate systems across the country. So it's very easy to drive to many places along the freeways. Now, in terms of going into some of the more remote parts of the country, that's still an issue that needs to be addressed. You can see on this map that there aren't a lot of, well, there's hardly any DC fast charging infrastructure serving the more remote parts of Nebraska. In the city, we are very well served. The orange pins on the map indicate DC fast charging sites. We have a Tesla supercharging site on North 27th near the Hy-Vee, and there's another one going in the west part of town. We also have an Electrify America fast charging site at Northwest 20th and O Street. And then we've got a couple of others located at Super Savers and Russell's Markets up at Fallbrook, out in Waverly, and also down at 33rd and Highway 2. And all the green dots, those indicate level 2 charging. All the downtown garages have them. And then there's also sites on the university campus, at LES's operations center, and a variety of other locations for folks that are needing to have access to level 2 public charging. These are the connectors that you would find at a charging station. The J1772 is pretty universal level 2 charging. Then the other 3 connectors are the 3 types of DC fast charging connectors. The Tesla has its own proprietary fast charging connector. The Chasm is a charging connector primarily for the Japanese or Korean-made vehicles, and then the CCS is for all the others, very common CCS DC fast charging connector. So we've covered a lot of bases here, and I want to allow plenty of time for Q&A. So I think at this time, let's open up questions here. We got about 20 minutes or so, and if there's been any entered in or anybody who'd like to ask questions live, we can do that now.
We've got some great dialogue going on in the chat box. So I'll read. I know there were some questions and some answers, but for the sake of the recording, we'll go ahead and go through all of the questions so that you can add to it. The first is actually a comment that Aptera will be manufacturing a 1,000-mile range model early next year. So that's just an FYI.
Say that again, Shereen.
Aptera will be manufacturing a 1,000-mile range model early next year.
That's very long range.
Yes. So our first question is, does a battery eventually die and then require the purchase of a new one? Are those costly? How and where are old batteries recycled?
A lot of good questions there, embedded in there. Most car manufacturers warranty the battery for 8 to 10 years. We're seeing batteries routinely get 100,000 miles of range or better. I think the early Nissan Leaf battery degradation was a little bit more aggressive than what we're seeing now. Degradation in the 1-2% range per year is not uncommon. But yes, I think over a period of time, the battery will need to be replaced, but it's in many respects, it's past 8 to 10 year period. There is a fledgling but developing recycling market for batteries where they may be recycled and reused or repurposed. So that is definitely in development right now.
How will Nebraska recover the gas tax to maintain roads? And then someone did respond saying that Nebraska adds a $75 fee to your
Right.
annual license renewal. I don't know if you had anything to add. Some states are twice as much as that.
Yeah.
Our next question is more about how much it costs to charge a full tank of electricity on a car. So it sounds like it'll vary with each model.
Yeah, so let's go back to the one about road taxes. Well, so that's a real issue, of course. We have relied upon the fuel tax to fund roads, and that model obviously needs to change. It needs to be changed so it's equitable and fair for everybody involved. And so, you know, I think about the electric industry and how we relied so much on kilowatt hour usage to pay for our fixed costs, and how we've evolved as energy efficiency has really tamped down a lot of growth in energy consumption, yet we still have fixed costs we have to pay for to provide reliable service. And so we've adapted by taking the fixed cost out of the variable kilowatt hour charge. And I think that same thing needs to kind of be considered for the road tax. We need to find a fair and equitable way of doing that, and that needs to be very carefully thought through because you don't want to. You want everybody who uses roads to help pay for those roads, but there's different mechanisms that could lead to unintended consequences. You don't want to overly burden electric vehicle drivers based on the model you use to recover those taxes. So there are states that are going through and making policy decisions and trying to figure that one out. What was the next question you mentioned?
It was about the cost to recharge a full tank, like what's the equivalent? So someone gave an example that their Model 3 standard is about $3 for a 200-mile charge. So
yeah,
a lot cheaper than.
The truth of the matter is that electric vehicle batteries, typically you don't go down to zero or anywhere near that. Usually a lot of the sweet spots between 20 and 80%. So usually putting, between 20 to 80% of the entire capacity of the battery in, you're talking about 6 cents a kilowatt hour. It gets you about 3 to 4 miles. So I have to go back in the math. You see there, it's just maybe a couple $3 for an equivalent range that you'd get from fuel.
Is there any plan to offer incentives to charge off-peak?
So that is something that is out there as a possibility. I think that what we're doing as a utility here is we're just monitoring. We don't have any significant concerns about electric vehicles and being able to serve electric vehicles. There may be a time in the future when there's much more adoption of vehicles that we might consider sending a price signal to encourage customers to charge off peak. What we found, interestingly enough, in our research that we conducted over 3 years, is that in terms of coincident to our system peak, which occurs usually late afternoon on a hot summer weekday, only about maybe 20% of vehicles that were in that study were charging at that time. There's quite a bit of diversity in when people charge their vehicles. There are already vehicle owners that are charging later in the evening or overnight. And one thing we didn't recognize and realize is that a lot of people don't charge their vehicles every day, particularly if you've got a longer range, all electric. You may charge a vehicle every other day or even every 3 days. So there's that to consider, that it may not be as much load early on than you think in terms of needing to send price signals. But I would expect at some point in the future that's something we'll look at. But you need to have the metering infrastructure out there that can signal and can assess rates that would comply with a kind of a time of use type rate.
Well, that leads into the next question. Is LES looking into any new rate structures or any type of load control devices as an option for customers that have in-home charging? And at what point will this be a necessity to prevent overloading the system?
Mhm. Yeah, so yes, we've looked at all those, and those technologies are developing and maturing. There is direct load control similar to what we have with peak rewards, where we are granted the ability to adjust the set points on smart thermostats. We have over 3,000 or about 3,000 devices currently. It would be run similar. We don't have a formal offering for electric vehicle charging at this time, but it is something that we do have in our toolbox if we want to roll that out. And then, of course, as I mentioned, the time of use rate is out there as well. That would require an investment in metering to some degree. Again, right now with a little over 1,000 electric vehicles, it's not an urgent issue. And of course, we work very closely with our colleagues in our energy delivery area to determine when would be the right time. We certainly want to do it proactively, but we also want to do it at the appropriate time and not so early where it maybe doesn't make a whole lot of financial sense. So there will be a time in the future when we see enough adoption where we will begin to roll those kinds of options out for our customers.
Do most of the public charging stations have multiple charger options for the different vehicles?
Yes, to some degree. I believe, well, when we say multiple charging options, so there are some charging stations that received funding from the VW settlement monies a few years ago that required to have level 2 as well as DC fast charging if they received money. What we're seeing, though, is a drive towards more DC fast charging along the highway corridors where level 2 isn't really going to be very practical in terms of the amount of charge that customers are going to want in a relatively small amount of time. And so you're going to have, you won't have as many level 2s or any level 2s at the DC fast charging sites. Now, there is usually what you'll find is a CCS and a Chasm connector available at a non-Tesla site. And then the Tesla stations have their own proprietary connectors. Now, what's happening is Tesla announced that they're going to start to introduce non-Tesla DC fast charging connectors, I believe CCS, at their sites over a period of time. This is already happening in Europe, and they're looking to do that at domestic locations. I don't know where, and I don't know how quickly this is going to happen. They're probably taking advantage of the fact that they have a very highly reliable network, and they have locations all across the country along the freeways. So there will be more and more options at those locations as well.
We have a couple related to capacity in the power grid, so I'll kind of summarize them together. But are power companies planning on adding capacity for everyone to switch over to EVs? Will their current power grid handle a mass adoption of EVs?
So the utilities are committed to providing whatever capacity is required to serve load, whether that's electric vehicles, whether that's load in industry, whether that's more electrified homes. I mean, it really doesn't matter. Utilities will add the capacity as they need to add the capacity. Those are always contained within load forecasts that our folks in our financial services area put together. And so we monitor all of those developments. As I did mention before, how much of this is going to have a near-term impact on our need to build more capacity? Rather modest right now, because again, we're seeing a lot of adversity. When people charge their vehicles, only a fraction of them are charging during the coincident peak. A lot of it is happening off our peak, and it's going to take a significant adoption and a significant amount of vehicles charging on our peak for us then to need to add capacity solely for that purpose. There are other forces, there's other types of load that may have even more impact on when we have to get into a new resource.
For someone who's interested in an EV, will they have to upgrade any electrical in their garage or have it inspected to be safe?
That's a good question. It depends on whether or not what your existing service is. For a standard 110, no. I mean, you just plug into an outlet in the garage and you're good to go. But if you want a level 2 station, then you would have to have an electrician come in and put in a 240 volt plug-in. I just recently built a home and put one in. It's a lot easier to do when you're building because it costs less. They're just going to put it in as part of the build. But if you want a level 2 plug-in at home in your garage, there is some expense involved in retrofitting your garage to handle that. And it's possible, depending on if you have a rather older home that may not have the capacity in the main service panel to handle that additional load, that you'd have to upgrade that. So it really depends a lot on what you currently have and what you're comfortable charging at.
Trickle versus fast charging, does it make a difference to the battery longevity?
No, I don't believe so. Actually, frequent DC fast charging will have a little bit more of an impact on battery life. So if somebody was DC fast charging their vehicle all the time, that would tend to degrade a little faster than standard 110.
Then this next one is kind of related to CO emissions. So there's been a focus that EVs are help reduce carbon emissions, but then the production is considered comparative, the production during the manufacture. So what is the response to that?
I don't have the citation or the specifics behind it, but this question's come up during my meetings at the Electric Power Research Institute, and they say even considering the manufacturing process for electric vehicles, the overall life cycle of an electric vehicle provides considerably less CO2 than a conventional vehicle, even when taking into account the full life cycle from its inception and its assembly and its manufacturing and all of its component parts to the end of its life.
Will LES curtail charging cars similar to California during high energy use or peak periods?
So the question is, would we curtail the
charging of cars?
So in the future, if we do offer demand response that includes electric vehicle charging, we would offer that up as an option. But we don't have built into our programs, even with our thermostats, that we mandate and take over control of in those situations. We don't go down to the device level for that type of use.
And then the last question is related to facility charge, whether or not LES has any plans to adjust facility charges or adding another level for those with EVs, since that bumps up their use.
So the current facility charges are based on energy consumption. And so I think that's pretty well factored in our facilities charge. So if you do have an EV and it bumps you from a tier 2 to a tier 3 or a tier 1 to tier 2, you're essentially going to be paying a little bit more in your facilities charge each month. But if you looked at the numbers between the $3.50 per gallon versus the 6 cents and maybe additional monthly fixed costs, there's still a pretty decent savings between electric vehicles compared to the conventional vehicle.
And then the last question, does Nebraska have any tax rebates or advantages for the purchase of an EV?
No, Nebraska has not offered anything of that nature from a tax perspective. There is the federal tax credit of 30%. Excuse me, I'm sorry, I'm thinking of solar, of $7,500. There are some new requirements for that federal tax credit, and those are now available across all manufacturers. There used to be a lid on manufacturers that they were only allowed 200,000 federal tax credits. And then once they reach that limit, they can no longer offer it. That's what happened with Tesla. I believe it happened with Chevy, maybe Nissan. Those were all done away with. But the new federal tax credit for purchase of electric vehicles, half of that federal tax credit is you're eligible if a certain percentage of the battery is sourced domestically or in friendly NAFTA countries. And that will ratchet up over the next 2 or 3 years, certainly at a point where 100% of the rare earth materials need to be sourced domestically or with a friendly country. The other half is how much of the battery is assembled here. And it is going to be similar, that at a certain point, in order to get that other half of the federal tax credit, a vast majority, if not all of the battery, will need to be assembled. And so there is some domestic development in assembly and rare earth sourcing that has to occur for folks to get that full tax credit in the future.
All right, well, that wraps up our webinar and all of the great questions. We had a lot of dialogue and engagement in the chat, so we are excited to see that. Thank you, everyone, for joining us today. We'll add a recording of this to les.com in the next week. If you've been following the LES Sustainability Series, our next upcoming event is this Sunday, September 25th. It's Streets Alive, which is in the Huntington Elementary School neighborhood. So from 1 to 4:30, you can bring your family. You can walk through LES Educational and Interactive Tiny House and watch a high voltage demo. All of those details are on our website as well, and we'll share the link. But thank you, Mark, and thank you, everyone, for joining us today.
Thank you, everybody. Have a great rest of your day.